It's a funny thing to think about. That shiny gold ring on your finger or the gold bar locked away in a vault didn't start here on Earth, not even close. Its story begins a long time ago in the unimaginable chaos of outer space. You see, gold is born from the most violent events in the universe. We're talking about supernovae, which are the explosive deaths of massive stars. Imagine a star many times bigger than our sun reaching the end of its life. It goes out with a bang so powerful it forges new, heavy elements in its fiery heart, and one of those elements is gold. It's not made, it's born in cosmic fire. So, you have all this gold dust floating around in space, the leftovers from these stellar explosions. But how did it get here? Well, billions of years ago, when our planet was just a young hot ball of molten rock, it was bombarded by asteroids and meteorites. These space rocks were carrying all sorts of materials, including that precious newly formed gold. For millions of years, these golden messengers from space crashed into our planet's surface. They delivered their cargo, seeding the Earth with this incredible metal. It's a wild thought, isn't it? The same material we dig out of the ground once traveled across the vastness of space. This cosmic delivery system explains why gold is scattered so unevenly across the globe. It wasn't part of Earth's original recipe. It was added later like sprinkles on a cake. Some areas got a heavy shower of these gold-bearing asteroids while others got very little. That's why you find rich gold deposits in places like South Africa or Nevada, but barely a speck in others. The gold settled into the Earth's crust as the planet cooled and formed over eons. It became part of the rock, waiting patiently for billions of years until someone came looking for it. It's a treasure hunt that started with a cosmic explosion. Thinking about it this way really changes how you see a simple piece of gold. It's not just a yellow metal, it's a piece of a dead star. It's a traveler that journeyed through the cosmos for an unimaginable amount of time before finding a home on our planet. Every ounce of it has an origin story that is more epic than any movie you'll ever see. It connects us directly to the violent creative forces of the universe. So the next time you see a gold coin, remember that its journey didn't start in a mine. It started in the heart of a dying star, a very long way from here. Now you might hear that Earth was showered with gold and think there must be tons of it everywhere, and you'd be right, in a way. Scientists figure there are about 48 billion tons of gold on our planet. That sounds like an incredible amount, a treasure trove beyond our wildest dreams. With that much gold, you'd think we could all have a solid gold house. But here's the catch, and it's a big one. The vast majority of that gold is completely, totally, and utterly out of our reach. It's a treasure we can see in our imagination but can never ever touch. It's the ultimate tease from Mother Nature. You see, back when the Earth was a hot molten mess, heavy things sank. It's simple physics. Gold is incredibly dense and heavy. So as the planet churned, almost all of that cosmic gold, more than 97% of it, sank deep down. It settled into the Earth's mantle and core, thousands of miles beneath our feet. We're talking about 47 billion tons of gold, locked away more securely than any bank vault. To get to it, you'd have to drill through 1,800 meters of solid rock, and that's just the beginning. The heat and pressure down there would crush any machine we could possibly build. So, what does that leave for us, the people living on the surface? A tiny fraction. Less than 1% of all the gold on Earth is located in the crust, the thin outer layer we live on. This is the only gold we have any hope of mining. It's the gold that got trapped in cooling rock formations closer to the surface. It's like finding a few crumbs left on the table after the entire cake has been put away in a locked pantry. This incredible scarcity is the #1 reason why gold is so valuable. It's not just that it's beautiful and doesn't rust, it's that there's so very little of it available to us. This is why the gold mining industry is such a massive and difficult undertaking. Miners aren't digging into a treasure chest. They are searching for microscopic flecks of gold hidden within immense mountains of rock. A really good gold mine might only yield about 1 ounce of gold for every 33 tons of rock they dig up. That's like searching a football field for a single lost coin. The sheer amount of work, energy, and money it takes to find and extract that tiny amount of gold is staggering. It's a tough, dirty job, all because most of Earth's gold is on a permanent vacation in the planet's core. Let's talk about the results of all this searching and digging throughout human history. For thousands of years, people have been obsessed with gold. From the ancient Egyptians to the California 49ers to the modern mining corporations of today, we have been tirelessly pulling it out of the ground. After all that effort, all those centuries of labor, you might wonder how much we've actually collected. The grand total of every speck of gold ever mined by humanity is estimated to be around 212,000 tons. Now that sounds like a lot, but let's put it into perspective. It tells a surprising story about just how rare this metal is. If you were to take all 212,000 tons of that gold and melt it down into a single solid cube, it would be smaller than you think. That cube would measure about 72 feet on each side. That's it. It would fit comfortably within the infield of a baseball diamond. The entire supply of gold ever mined in the history of the world could be contained in a structure that is only about 6 stories high. Every royal crown, every gold bar in every central bank, every wedding ring, every golden idol, all of it would fit into this one surprisingly small cube. It shows you that for all our obsession, gold is not something we have in abundance. Here's another way to think about it. Gold is incredibly malleable and ductile, meaning you can stretch it out into a very, very thin wire. If we took that same cube of all the gold ever mined and stretched it into a wire that was just 5 microns thick, that's thinner than a human hair. We could do some amazing things with it. That single wire would be long enough to wrap around the Earth at the equator 11.2 million times. It's a mind-bending contrast. All the gold in the world can fit in a small space, yet it can also be stretched to cover an astronomical distance. This property is part of what makes it so useful. This scarcity is what drives the whole industry. In 2024, the world's mines produced about 3,638 tons of new gold. That's a massive effort, involving hundreds of thousands of workers and billions of dollars in equipment, all to add a tiny sliver to that existing cube. Each year, we add just a little bit more to the global supply, but it's a slow, expensive, and incredibly difficult process. We've likely already found most of the easy gold. The gold we're mining today is harder to get to and exists in smaller concentrations than ever before, making every new ounce a hard-won prize. When you think of gold mining, your mind might jump to the old stories of South Africa. For a long time, that country was the undisputed king of gold. The Witwatersrand Basin was a geological marvel, a source of a huge portion of the world's gold for over a century. But times have changed. While South Africa still has some of the deepest mines in the world, its production has dropped significantly. The easy-to-reach gold is gone, and mining there has become more difficult and expensive. The torch has been passed to a new set of global players who are now leading the charge in the modern gold rush. Today, the map of gold production looks very different. The #1 spot is now held by China, which has ramped up its mining operations dramatically over the last couple of decades. They are followed closely by countries like Russia and Australia. These nations have vast, relatively unexplored territories and have invested heavily in modern exploration and mining technology to unlock their geological wealth. Canada and the United States also remain major players, with large-scale mining operations in states like Nevada and Alaska. The gold rush hasn't ended, it has just shifted its focus around the globe. This shift tells a story about technology and geology. The old gold rushes were often about a lucky prospector finding a huge nugget in a river. Today it's a much more scientific and industrial process. Geologists use satellite imagery and sophisticated sensors to find signs of gold deposits deep underground. It can take 10 to 20 years from the moment a deposit is discovered to the day the mine actually starts producing gold. It requires massive investments in infrastructure, equipment, and permits. The days of a man with a pan and a mule are mostly over. This is the era of multinational corporations and high-tech exploration. So while the global output in a year like 2024 reached an impressive 3,638 tons, it's important to remember where that comes from. It comes from these industrial powerhouses, which are constantly pushing the boundaries of mining. They are digging deeper, processing more rock, and moving into more remote locations than ever before. The hunt for gold is now a global enterprise, a competition between nations to extract one of the planet's rarest and most sought-after resources. The gold rush continues, but the prospectors now wear lab coats and operate billion-dollar machinery. So, how do we actually get this stuff out of the ground? It's a dirty, difficult job, and honestly, there isn't just one way to do it. The method miners use depends entirely on where and how the gold is found. Broadly speaking, it boils down to 3 main techniques: open-pit mining, underground mining, and placer mining. Each one comes with its own set of tools, its own dangers, and of course, its own impact on the land. The first and most visible method is open pit mining. This is probably what you picture when you think of a massive modern mine. It's used when the gold is scattered in tiny particles throughout a large body of rock close to the surface. To create an open pit mine, you have to move a mountain to find a molehill. Miners use powerful explosives to blast away layers of surface rock called overburden to get to the gold-bearing ore beneath. Then giant trucks that can carry hundreds of tons of rock in a single load haul the ore to a processing plant. The mine itself looks like a massive terraced bowl dug into the earth, growing wider and deeper over time. It's a less expensive way to mine on a huge scale, but we're running out of surface deposits that are rich enough to make this method profitable. It's brute force on a colossal scale. When the gold is buried deep underground in veins or loads of concentrated ore, open pit mining just won't work. That's when you have to go underground. This is some of the most difficult and dangerous work on the planet. Miners dig vertical shafts that can go down for miles and then excavate horizontal tunnels or drifts to follow the gold veins. The deepest gold mine in the world, Mponeng in South Africa, goes down over 2.4 miles. Down there, the rock temperature can reach 140 degrees Fahrenheit, and the pressure is immense. It's a dark, hot, and cramped world where the risk of a tunnel collapse is a constant threat. It's a tough way to make a living. The third method is the oldest and simplest of all placer mining. This is the classic gold rush technique you see in old movies. It works because gold is incredibly dense, about 19 times heavier than water. Over millions of years, erosion can wash gold out of rock veins and carry it into rivers and streams. Because it's so heavy, the gold settles at the bottom of the riverbed in gravel deposits called placers. A prospector can then use a simple pan, sloshing water and gravel around until the lighter sand washes away, leaving the heavy flakes of gold behind. It's a method that relies on gravity and a strong back, connecting modern miners to the earliest prospectors in history. Section 6. From dirty rock to gleaming bar. The refining process. Pulling a chunk of gold-bearing ore out of the ground is just the first step in a very long journey. The gold that comes from a mine isn't shiny and pure. In fact, you probably wouldn't even recognize it as gold. It's mixed with tons of other rock and minerals, and the raw material that's extracted is typically only about 60 to 90% pure at best. To get to that familiar, gleaming 24-karat shine, the ore has to go through an intense, multi-stage refining process. The first part of this job is all about brute force. It's about making big rocks into little rocks, and then into fine powder. The process begins with crushing. Giant machines with powerful metal jaws take the huge chunks of ore from the mine and break them down into smaller, more manageable pieces. But that's not nearly small enough. From the crusher, the ore is moved to enormous rotating drums called ball mills. These mills are filled with heavy steel balls. As the drum tumbles, the steel balls grind the ore, smashing it over and over again until it becomes a fine powder, almost like sand or flour. The whole point of this is to liberate the tiny microscopic particles of gold from the surrounding rock they are trapped in. Once you have this fine powder, the next step is to separate the heavy gold from the lighter waste material. One of the oldest methods involves using a liquid solution, often containing cyanide. The powdered ore is mixed into a large vat with the solution, which dissolves the gold and leaches it out of the rock. The gold-rich solution is then separated from the solid waste. This method is very effective, but the use of cyanide is highly toxic and poses a serious risk to the environment if it's not managed perfectly. Other methods use gravity or centrifugal force, spinning the material at high speeds to separate the dense gold. Finally, it's time to purify the gold. The concentrated gold is melted down at incredibly high temperatures, over 1,947 degrees Fahrenheit. A chemical mixture called flux is added to the molten metal. This causes the remaining impurities to separate and rise to the top, forming a layer of waste called slag, which is scraped off. For even higher purity, refiners use advanced methods like the Miller process, which uses chlorine gas, or the Wohlwill process, which uses electrolysis to achieve 99.9% purity. The pure, liquid gold is then poured into molds, where it cools into the familiar bars we see in pictures. Each bar is then stamped with a serial number and a purity mark, ready for the world. Section 7. More than just bling, what we do with all that gold. After all that hard work, the cosmic journey, the deep earth mining, the intense refining, where does all this gold actually end up? What do we do with the 3,638 tons pulled from the ground in a year like 2024? Well, the biggest and most visible use for gold by far is jewelry. About half of all the gold mined each year is destined to become rings, necklaces, bracelets, and earrings. Its beautiful luster, its resistance to tarnish, and its cultural significance as a symbol of wealth, love, and status make it the perfect metal for adornment. For centuries, it has been the ultimate way to show off. To make jewelry, goldsmiths take the pure 24-karat gold and often mix it with other metals like silver, copper, or nickel. This is done for two reasons. First, pure gold is very soft, so adding other metals, creating an alloy, makes it much more durable and suitable for everyday wear. Second, it allows for different colors, like white gold or rose gold. The metal is heated until it becomes soft and workable. It can then be rolled into sheets, drawn into wires, and expertly crafted into intricate designs. After hours of careful shaping and polishing, it becomes the beautiful jewelry we see in storefronts. But gold isn't just for wearing. A huge amount of it serves a very different purpose, as a store of wealth. Central banks around the world hold immense reserves of gold bars in high-security vaults. For example, the US Federal Reserve holds thousands of tons of gold for countries all over the globe. This gold acts as a financial safety net. Unlike paper money, its value doesn't depend on the decisions of a single government. It's a physical asset that has been trusted for thousands of years, making it a safe haven for investors and nations during times of economic uncertainty. Many individuals also buy gold coins or small bars for the same reason. Beyond jewelry and finance, gold has some critical, high-tech applications. Because it is an excellent conductor of electricity and doesn't corrode, it's used in small amounts in almost every sophisticated electronic device you own. Your smartphone, your laptop, and your television all have tiny amounts of gold in their circuitry, ensuring reliable connections. It's also used in dentistry for crowns and in the aerospace industry to coat satellite parts and astronaut visors, reflecting harmful solar radiation. So while you may think of gold as just bling or money, it's also a critical industrial metal that makes much of our modern technology possible. Section 8. The high price of gold. The dark side of mining. The gleam of gold is so captivating that it's easy to forget the true cost of getting it. The story of gold is not just one of treasure and beauty, it's also a story of destruction and human suffering. This is the part of the job that doesn't make it into the glossy brochures. The environmental impact of large-scale gold mining can be devastating. Open-pit mining, for example, requires clearing huge areas of land. We're talking about tearing down forests, rerouting rivers, and literally moving mountains of earth. This destroys natural habitats and can leave the land so scarred and polluted that it's unusable for farming or anything else for generations. The pollution doesn't stop there. The chemicals used to separate gold from ore are a major problem. For over a century, miners have used mercury and cyanide to extract gold. Both are incredibly toxic. When these chemicals leak or are improperly disposed of, they get into rivers and groundwater. This poisons the water supply for entire communities, killing fish and other wildlife. The health effects on people who drink or use this contaminated water can be severe, leading to neurological damage and other serious illnesses. While many countries have banned mercury, it is still used in many small-scale, unregulated mines around the world. Then there is the human cost, which is perhaps the most tragic part of the story. Gold mining is dangerous work. In large industrial underground mines, workers face the constant risk of tunnel collapses, explosions, and heat stroke. In smaller artisanal mines, the dangers are just as real. People wading in rivers for placer mining can be swept away by strong currents or suffer from skin diseases after spending hours in dirty water. They are often working with little to no safety equipment, risking their lives every day for the chance to find a few specks of gold. Worst of all, the gold industry is plagued by issues of exploitation and human rights abuses. In some parts of the world, the promise of gold creates a desperate situation. Entire families, including young children, are forced into labor, working grueling hours for just a few dollars a day. They are trapped in a cycle of poverty, digging for a treasure they will never be able to afford. Reports from places like Brazil have shown that a shocking number of miners are victims of human trafficking, lured by false promises and forced to work against their will. This is the dirty secret behind some of the world's most beautiful objects. Section 9. A precious metal with a heavy cost. So there you have it. The incredible journey of gold, from the heart of a dying star to a vault deep beneath a city street. It's a story of cosmic violence, geological patience, and human ingenuity. We've seen how its extreme rarity, with most of it locked away in the Earth's core, is what makes it so precious. We've looked at the sheer scale of the effort it takes to add just a few thousand tons a year to the small cube that represents all the gold ever mined. It's a testament to our fascination with this one-of-a-kind element, a fascination that has driven people to the ends of the Earth. We've walked through the different ways people get their hands dirty to get it, whether it's blasting away mountains in an open-pit mine, descending into the hot, dangerous depths of an underground tunnel, or panning patiently in a cold river. And we've followed the path from a dusty, worthless-looking rock to a gleaming, pure gold bar through a complex process of crushing, melting, and refining. It's a dirty job, a tough job, and a highly scientific job all rolled into one. The result is a material that builds our most treasured jewelry and backs our global economies. But it's impossible to tell this story honestly without looking at the dark side. We can't ignore the scarred landscapes, the poisoned rivers, and the immense environmental toll that gold mining can take. We have to acknowledge the human cost, the dangerous working conditions, the exploitation, and the poverty that fuels so much of this industry. For many people involved in mining, the gold rush is not a story of riches and adventure. It's a story of survival, of hard labor for little reward, and sometimes of modern-day slavery. It's a heavy price to pay for a shiny metal. In the end, gold is a paradox. It is both wonderful and problematic. It represents the best of our creativity and the worst of our greed. It is a symbol of love, beauty, and security, but it can also be a product of destruction and suffering. As we continue to dig for it, we have to ask ourselves hard questions about how we can do it better. How can we reduce the environmental damage? How can we ensure that the people who do this dirty, dangerous work are treated fairly and safely? Gold will always be precious, but its true value should be measured not just by its market price, but by the respect we show for our planet and for each other in our quest to obtain it.